Thanks for having me here. Today I'll be talking about how to find and exploit talk to issues in web apps with OWASP time gap theory. My name is Abhi Balakrishnan. I work as a security consultant for Security Compass, San Francisco, USA. The topic of ours today is OWASP time gap theory, which is an open source project. It is a capture the flag. You can call it a talk to GOAT or race condition GOAT, since it is a capture the flag or deliberately vulnerable application focusing only on talk to issues. It doesn't have, it may have some other security issues, but the focus is on talk to. It is a free and open source project, and it is from OWASP. Just a little bit of disclaimer before going ahead. This is a personal project. It is not connected to my employer. Opinions, code, ideas are all my own. This is going to be our agenda for today. I'll explain what is talk to, what is OWASP time gap theory. I'll walk through a challenge. In those, you will learn tools and techniques in the industry for finding and exploiting to talk to issues. Then finally, why should you care about these issues? By the end of the session, you will be a talk to hero, that I can promise. Throughout this session, I may use these terms interchangeably, but what I'm referring to is talk to. The talk to is an abbreviation for time of check to time of use. Some people call it as concurrency issues as well. These all are happening due to a race condition. So sometimes people generally call talk to issues as race conditions. First, I want you to understand this video. In this video, chess number 8, the person in blue, they check around to make sure that they are going to win, and they are advancing in the race, and they think that they are safe, and they are starting to celebrate. And you can see that there is another person in red, chess number 1. They overtook person 8, and they won the race at the end. So there was a time gap between when the person in blue checked whether they are ahead in the race or not, and the final checkpoint, which is the finish line. This is the Wikipedia definition for talk to. We will walk through line by line. The first line says time of check to time of use, which is talk to. Then it says talk to is a class of software bugs. So it is a software bug, it's a security issue, at least up until that we are clear. Then the third line says it is caused by a race condition. So it is, all of those are introductions. Now we will talk about the actual issue, the last 2 sentences. So the fourth sentence, the second last line says, talk to involves the checking of the state of a part of a system. So in the previous video, checking is when that person looked around and made sure that they are winning in the race. So checking of the state of a part of a system. And the last line says, and the use of that result, use of the results of that check. So they are using that result on the finishing line, but within that time, the state of the result must have changed. I mean, they are not in the first place anymore, but they did not know that because there was a time gap between the checking and the actual use, and within that time, the state changed. So that caused the issue. So the similar steps can happen in softwares, and that's what we are going to discuss today. This is the first time in 2015, I saw this article, and that's the time when I came to know about race conditions or talk to issues in web applications.
I'm sorry, we see only the application, we don't see really the slide there. Nothing is moving. So I think you showed not a good stream.
Okay, let me share that again.
Now we see the good slide. But like I said, we didn't see anything before, so just having an idea of what you showed.
Are you able to see the slides changing?
Yes.
Okay, perfect. So this is the Starbucks article I was talking about. Then that's when I came to know about this particular issue. What happened there was that it was back in 2015. That issue does not exist anymore. You basically purchase 2 or 3 gift cards from Starbucks. You go back home and say, for example, all of them have $10 on all of them. Then you go online to Starbucks website and you try transferring money from one gift card to the other. And the transfer will happen without any issues as long as you have sufficient balance. So when you perform this type of transactions, the transactions are not happening physically, right? You are not taking money from someone's account or someone's gift card and putting it in someone else's account. What is happening is that the application will check whether the card has sufficient balance or not. If there is sufficient balance, it will reduce that particular amount from the sender and will add that particular amount on the sender, receiver's account. So that's what the application logic would look like. So this is the application logic on a very high level. On step 1, user initiates the transfer. On step number 2, I'm showing an application. It can be PHP or any other application. It checks whether the user or the card has sufficient balance. That information must be stored in the database. So it will check the database. Then on the 3rd step, if there is sufficient balance, the app will add points or money to the destination and it will write to the database. Then it will also reduce, on step number 4, it will also reduce points or money from the sender, and it will make the corresponding changes in the database as well. If, for example, on step number 2, if there is no sufficient balance is available, you can see on the 5th step that the app will error out. The problem with this approach is that, say, for example, if a user is initiating 2 transfers at the same time, say, for example, I'm opening money transfer pages on my browser and a phone, or 2 browsers at the same time, then I click on the transfer button together at the same time. Then there will be 2 threads. Applications are designed to be threads. So these threads, both of these threads, or if I have clicked that button many times, that many threads will be there. Those threads will check whether the user has sufficient balance or not. If since all of these are happening together, all the threads will get a response that, hey, it has sufficient balance. Then the application will take care of adding the amount to the receiver, reducing that from the sender, which means the successful transfer can happen more than 1 time. That means you make money out of thin air. So that's what happened with Starbucks as well. When you did that with Starbucks, if you transfer, say if you have 2 cards and both of them have only $10, and if you transfer from one card to the other $10 in parallel requests, on the receiving side, you may have received $20 or $30. If you have 3 threads, you will see $30. And the first card will be having negative balance because that amount will be removed from the sender. But these are gift cards. You can just throw it away. So the negative balance is not going to affect you. But on the other card, you have sufficient balance now. Even though you purchased 2 cards with $10 each, which costed you $20, now you have a card with $30 or $40 with you because of race condition, and you can go to store and purchase whatever you want. So in order to show that, I did the same thing on our CTF as well, or as time gap theory. So this is a demo of that happening. I will walk you through the demo, and we'll talk more about it. So what I'm going to do is that I'm going to web app. I'm resetting the database, then creating default users. So you can do that in time gap theory. You create default users, and these 4 users will be created: Tom, Jerry, Spike, and Tig. All of them will be having email addresses of Tom at timegaptheory.com, Jerry at timegaptheory.com. So first name at timegaptheory.com would be their username. The password would be their name in lowercase. So Tom's password would be lowercase TOM. So I'm logging in with that information. In time gap theory, you don't have to enter those information yourself. You can click on that button and the form will be saved, filled automatically. So I'm doing that. Then I'm going to the transfer rewards page. And if you see, you can see that Tom has a balance of 100. In brackets, you can see that Tom has a rewards of 100 and Jerry has 900. So from Tom's account, I'm going to transfer $90 for 90 reward points. So if I click transfer, it will go through. But if I do it again, it will say you don't have enough rewards because I have Tom only has 10 reward points now, so you can't transfer 90. So that check is really happening. I'm clicking on create default users again so that the accounts will be reset. Then I'm logging in as Tom again. Tom has 100 reward points. I'm going to settings and I'm adding main weight. Main weight is a method. If you add 5 seconds there, what will happen is that for every write operation to the database, in time gap theory will wait 5 seconds. That will give us avenue for breaking in and exploiting the security issue. In real life, you can't use this feature because it is only available in time gap theory, but it is only just for our understanding how it works in a very high level. There are other tools and techniques to use in real life, but for now, to understand the problem closer, we will add a delay. Then I'm saving, I'm going back to my account, logging in as Tom. Okay, I have 100 reward points. I'm performing the transaction again, but this time I'm not clicking on the transfer button. Instead, I'm opening up a new browser window, a private window this time, and navigating to the same page by logging into the account so that we can have a similar request, like 2 parallel requests. I'm logging in as Tom. I'll go to the transfer rewards page there as well. Just to check, we will check if you go to admin managers, yes, you can see the reward points of each user. So if you see Tom has 100, Jerry has 900, Spike and Tig has 1,000 and 2,000 reward points respectively. I'm going there, I'm performing the transaction again, and this time I will click on transfer button on both the browsers as fast as I can within that 5 seconds window. You can see that both the pages are loading and both of them completed loading. Now, if you refresh the page, you can see that there is a negative points on Tom's account and Jerry has received more than we have imagined. So this is how the talk to issues really happens. If you go to score page, you can see that you have completed the transfer challenge. So that is how the talk to works. That's how it happened in Starbucks. Now, In 2016, there was a talk in Hackfest. Aaron, who was a colleague of mine, he introduced a tool called Raise the Web. I love that tool. It makes things easy to find and exploit talk-to issues in web applications. I'll really recommend you to go and check it out. It's available on YouTube. In this, he have talked about how to find talk-to issues and also how to safeguard your applications against from talk-to issues. I'm not discussing that particular topic in here, but if you want to know how to secure your applications, you should definitely watch that talk. But our topic is, why just money transfer? After the Aaron's presentation in Hackfest, after that Starbucks incident, I started exploring about this particular issue. I saw several blog posts, several research papers, lots of YouTube videos, lots of people made a blog post about this, but all of them talked about the scenario we have seen before, money transfer or reward points transfer, those type of scenarios. And I was thinking, hey, maybe there can be more avenues in applications where talk-tos can be present, not just money transfer scenarios. That's why I came up with this project called Avast Time Gap Theory. In this, we have 7 unique challenges or 7 unique scenarios where talk-to issues can happen. So if you look at the first challenge, on the sign-up challenge, you can see that by exploiting talk-to issues, you can create 2 users with the same email address and same username on an application. You can, on the second challenge, you can say that on the login challenge, you can bypass brute force prevention mechanisms by exploiting talk-to. So there are 7 such challenges. We looked at the third challenge of transferring more money than what you have. And similarly, there are other challenges. You should really check it out. Our website is timegaptheory.com. You can see the tutorials, guides, videos, etc. there. So talking about Avast Time Gap Theory, it's a free project. It's an open source project. Like I said, it is a CTF style vulnerable app. So when you solve each challenge, you will get points automatically. You don't have to find a flag and fill it somewhere. On the server side, there is a logic to check whether you are performing the right actions or not, and you will get points for that. If you want to test it or set up a home lab and try it on your system, you can use a Docker version of Time Gap Theory. I will really recommend using that because with that you can go crazy, right? You can use whatever tools you want, and you can be really brutal about it. If you don't want to set up a home lab, if you don't want to use your system, then there is a Heroku version as well. You can spin a Time Gap Theory instance online for free on Heroku. It has bullet time feature. That is the feature you have just seen. You can increase the time delay so that you can understand the problem better. Then later on, you can use tools and nullify the delay or bullet time feature and see if your methods are working so that you can use the skill set in real world applications. It also has dark mode and snow mode, which can be easy for the eyes and help you protect privacy. This is how the home page of Time Gap Theory will look like once you run the lab. You see 3 buttons on the top right side. We will talk about those. So this score page is where you can see the progress of your score. Web app directory is where all the challenges are. You may have to limit all your exercise to that particular directory because all the other directories are for setting up the applications or changing the settings. Settings page is where you can change the delay or customize the write time delay to the database. So there is one challenge going to Mars. That challenge has a separate delay. So that is the Mars wait delay. All the other challenges have main wait delay. You can also decrease maximum login counts on the third setting. Sign up page is where you can sign up for. So we are looking at a challenge now, sign up challenge. That is where you don't have to fill up all these details. Like I said before, you can click on each user button and it will fill the form automatically. So this is how a sign up page will work. Any sign up page in any application, you enter your email and password. Then the application will check the database. On step number 2, you can see that it is checking whether the email exists on the database or not. If it is already in the database, that means the user is signed up for an account already. So then they don't have to create an account. If a user account is not found already, then it will create a user account. So this is how a sign up flow will work. We are looking at a sequence diagram. So user is entering email and password. Application is checking email exists already in the database or not. Database will say no. Then the application will say ask the database to create a user account entry. So what if we open up 2 browsers, enter the same email and password on both the browsers, and click on the sign up button together? Both of them will go to the application. Both of them will check the database, whether the email already exists in the database or not. Both the threads will get a response from the database saying that, hey, I don't see a user account with the same email address or username. Then the application will ask the database to create 2 entries, 2 user accounts. We will see that in action using bullet time. So I'm clearing the database. I'm going to the sign up page. I'm clicking on the button Tom and submitting it. I did that once, I did that twice, and it says account email address exists, or it means already exists. So you can't create 2 user accounts if you just do that from one browser. We will clear the database again. Now we are adding a delay of 5 seconds so that we will have some avenue to exploit it. Okay, we are using Jerry account this time. So I have 2 browsers open, and on both of them I have filled the form with the user information for Jerry. We will click on the submit button on both browsers as fast as we can. We just need to do it in 5 seconds because we have bullet time feature helping us. All right, both the pages are loading up. Okay, both the pages loaded up. So if you go to manage users, you can see that there are 2 user accounts with the same email address. You may ask, what is the impact of this thing? So say, for example, an attacker, a malicious person can go to any website and create 2 user accounts. Then they have 2 user accounts there. And a legitimate user may receive an email saying that, hey, there are 2 user accounts created on this particular application, and please confirm your email address. And they may say, hey, I did not create this user account, but I wanted to, but I don't want anybody to take care of those accounts. I will claim that account. So they may go through the verification process, set their own password on one account, but the other account will continue to have the same old password that hacker has set, and that way they will have a permanent backdoor to the user's system. Or how depending on how the application is designed, the attacker may have access to the money or sensitive information stored on the application, etc. It's all based on how the application is designed. So we have solved that challenge. If you go to score, you can see that you have gained points for completing the first challenge. So this is how you can solve the challenge using bullet time feature, but it is only available in time gap theory. So what if you want to do it on a real application where in which you can't change the database right time? So we don't need complicated tools for that. We have enough tools in browsers itself. So we will see about that. So I'm going to solve the same challenge, but using browser dev tools. I'm clearing this code to make sure that our state is clear. Then I'm clicking on the Tom button and creating an account. And yeah, it is not allowing me to create an account again. This time I will click on inspect element so that browser DevTools will open up. And then I will submit the same request again. And in the network tab, I can see the request. So right click on that and copy the request as fetch. Then go to the console tab of the browser DevTools, paste that particular request. We already created an account with Tom, so we will change the username to DevTools this time and the password to DevTools. And we need multiple parallel requests. So we will copy this particular request and paste it a couple of times. So I'm doing it only twice. Then I'll click on the enter button. And if I go back to admin manage users, you can see that there are 2 users with the same name, email address, and password. This is how you solve using browser DevTools. So there are several methods to solve to find and exploit talk2 issues. I'm going through all of them so that if one technique doesn't work, you can use the other techniques. So now we know how to solve this particular challenge using bullet time feature and DevTools. We will see a third technique using curl. So what we are going to do this time is, instead of copying it as a fetch request, we will copy it as a curl request. We'll see how that works. So we have a sign up request. I'm copying it as curl this time. Open up a notepad and paste it over there. Then we don't need all these headers. We can remove what unnecessary headers, and we just need bare minimum version. Then you put an ampersand symbol, then copy paste the same request again. And when you put an ampersand symbol, curl is going to execute both the commands together. Now you go back to your terminal, then paste it, you press enter, and both the requests will go together. Let's refresh our admin page, and you can see that there are 2 user accounts with the same name and email address. That's how you use curl. We also talked about raise the web tool by Aaron. So we will see how we can solve the same issue with raise the web. I like this tool very much because it gives you a lot of freedom. You can specify lots of many parameters. It can fit in CI/CD pipeline. So if you are working in an organization and you want all the applications to be tested, this is the best. So let's see how that works. With Raise the Web, you don't need all these. What you need is a TOML file so that Raise the Web can understand what kind of request it needs to send, what type of data it needs to send. So I have created a TOML file with all the details. I'm clearing everything, and this is how the TOML file would look like. You will have on the line number 3, you can see that how many requests I need to send. So it says 10 requests, and the request details are from line number 6 onwards. It says it needs to be post request. This is the URL. This is the body. You do that, and you execute Raise the Web by supplying the TOML file. So right now I don't have any users. I have the TOML file ready. I'll go to my terminal and execute Raise the Web. Okay, it's done. Now, if I go back to my browser and refresh the page, I'll see that, hey, it has created 3 user accounts. We sent 10 requests, but only 3 of them got succeeded. So that's how you solve the same challenge using Raise the Web. Now, talk2 was never in OWASP top 10. talk2 was also never in SANS top 25. So what this means is that even though it is not in Avast top 10 or it is in SANS top 25, it is a serious security issue. So for an attacker, they necessarily don't have to find the security issue within Avast top 10 or SANS top 25 to attack your application. As a defender, you need to make sure that all the open doors are closed. But for an attacker, they just need an open door. It doesn't necessarily have to be from Avast top 10. So it is important. These issues were very hard to detect. People never used to test this much, talk to issues or race conditions in general. But now we have tools and techniques to find these issues. We have a platform to practice and better our skill set. And I'll really recommend testing your applications against top 2 issues. In 1993, at least 3 patients died and several people got injured due to a race condition issue in a radiotherapy system. So when it is a life-critical system, application, or machine, race conditions or top 2 issues can really be lethal. The Northeast blackout of 2003, which was a widespread power outage here in USA and Canada, was also caused by a race condition bug. So these issues, even though they are not in Avast top 10 or SANS top 25, are really bad issues. Like I said, attackers just need one open door, and it can be anywhere. And that would be all. Thank you. If you have any questions, please let me know here, or you can reach out to me later on if you want. Our website is timegaptheory.com. We have a presence in Reddit, or you can reach out to me personally on LinkedIn, Facebook, or Twitter.